Now that we have studied the two categories of friction, that is static friction and kinetic friction, now we will learn about rolling friction. As the name suggests, rolling friction, like how we saw in case of static. Static means something at rest. So the friction which comes into play for objects at rest. Similarly, kinetic friction. The term kinetic means moving. So kinetic friction comes into play for objects which are moving. Similarly, rolling friction. The name suggests rolling means for objects which generally roll. For example, let us see, rolling friction is applicable for bodies whose point of contact keeps changing. Can you think of such bodies whose point of contact with the surface keeps changing at every interval? Yes, you can. Just think of any spherical object. Let us say, think of a ball. When a ball moves along a surface, the surface of contact or the point of contact of the ball with the surface doesn't remain the same. It keeps changing as the ball keeps rolling. So rolling friction is applicable for objects like that. For objects for whom the point of contact with the surface keeps changing very frequently. Let us suppose instead of the box we have this ball now. See it once again. The ball is rolling. So initially the point of this, suppose at this time the point of contact is this. Again when it rolls back somewhat like this, the point of contact becomes this. Sometimes this or so on. So we don't know which will be the point of contact. So as it keeps rolling, the point of contact keeps changing. So for such objects, be it a spherical ball or be it a ring or anything like that, or a spinning top, so for all of them, rolling friction comes into play. Now what exactly happens during this rolling friction is that the surfaces you must be wondering, because the point of contact keeps changing. So you must be thinking that how come the force of friction starts working when there is no particular point of contact or there is no particular surface which is in contact. What exactly happens is, during rolling, the surfaces in contact gets deformed momentarily. That is, for a very small interval of time, the point which comes in contact with the surface, it gets deformed, which results in a finite area being in contact with the surface. That means, let us suppose, I'll draw it separately here. Let us suppose this is the ball. When this ball is rolling on this surface, now when this ball is rolling on the surface, a small point on the ball, for momentarily it gets deformed. As a result, a finite area of the ball comes in contact with the surface. And as a result of this contact, a force which is parallel to this surface opposes the motion, and that force is nothing but rolling friction. I hope you understood it. Since the diagram is not that clear, I'll tell it once again. Let us suppose this is the ball and this is the surface. So normally what happens is, a single point almost comes in contact with the surface. But for a very small moment of time, there is a small deformation of this surface. As a result, almost you can say a small flat surface comes in contact with the table. As a result of this surfaces coming in contact, there is a force parallel, there is a contact force rather parallel to the surfaces in contact which comes into play, and that force is rolling friction. So force that opposes the motion of a body which is rolling over the surface of another. So what was static friction? It was the force which tried to oppose the motion which was about to start. So when we talked of kinetic friction, it opposed the motion of a body moving on the surface of another body. Now when we are talking of rolling friction, it is opposing the motion of a body which is rolling over the surface of another body. Now let us look at certain examples of rolling friction. The most common example is the wheel. The wheels in all your vehicles, they all work with rolling friction, because as you can see here, when the wheel rolls, the point of contact of the wheel with the road keeps changing with time. It changes like this. So here also the rolling friction comes into play. Similarly, you can think of the bowling balls. It rolls down this plane, the smooth lane which you see, it rolls down the smooth lane. So there also the similar thing happens. So any spherical or circular object which generally have a tendency to roll on the surface of anything, you can even take the example of a spinning top. Whenever they all move on a surface, rolling friction comes into play. Now, let us have a comparison of rolling friction with static and kinetic friction. Earlier we already saw the comparison between static and kinetic friction. What was that? Let's quickly review. We saw that the coefficient of kinetic friction is always lesser than the coefficient of static friction. So here what did we see? The coefficient of rolling friction is lesser than that of kinetic friction. That means the order of all the three types of friction would be rolling friction lesser than kinetic friction less than static friction. That means it says, the first point says coefficient of rolling friction, that is mu r, is lesser than coefficient of kinetic friction, which is again lesser than coefficient of static friction. So since we know for all of them, if we multiply n on with all of them, that doesn't matter mathematically, and we can write this as the rolling friction. Then we can write this as kinetic friction, and we can write this as static friction. So the value of static friction is the highest of all the three categories of friction, and the value of rolling friction is the lowest of all the three.